Hello friends, today we are going to talk about something very interesting. It is not about politics or history, it is about data. Data is everywhere around us. The marks you get in school, the runs a cricketer scores, the temperature of your city. All of this is data. But what do we do with all this information? The answer is a special tool for your computer. This tool is called Pandas. It is a library in the Python programming language. Think of it like a magical box of tools that helps you work with data very easily. It is not the black and white bear, but it is just as loved in the world of data science. So, what exactly is data science? It is the job of understanding stories hidden inside data. People who do this are called data scientists. They are like detectives. They look at numbers and find important information. This information helps big companies make better decisions. It helps doctors find new treatments. It even helps governments plan for our future. For all these data detectives, Pandas is one of their most important tools. It helps them clean data, change it, and ask questions to the data. Without a tool like Pandas, working with large tables of information would be very difficult and time-consuming. Why is Pandas so popular? The reason is simple. It makes difficult tasks very easy. Imagine you have a big notebook with thousands of student names and their marks. If I ask you to find the student with the highest marks, you will have to look through every single page. This will take a lot of time. But with Pandas, you can do this in just 1 second with a single command. The first step in any data journey is to get your data. Most of the time, data is stored in files. One of the most common file types for data is called a CSV file. CSV stands for comma-separated values. It is just a simple text file where data is stored in a table format, and each value is separated by a comma. For example, a file with student information might look like this: name, subject, marks. Then on the next line it would say, Rahul Maths 85. It is a very simple and organized way to store data. Pandas makes it incredibly easy to read these files and bring them into our program for analysis. To load a CSV file, Pandas has a very helpful function called read_CSV. It's a simple command that does a lot of work for you. Let's imagine we have a file named student_marks.csv. This file contains the marks of different students in different subjects. To load this data, we first need to import the Pandas library. We usually do this with the line import pandas as PD. Here, PD is just a short, convenient nickname for Pandas. Then we use the read_CSV function. We can write something like this: df =pd.read_CSV, student_marks.csv. This one line of code tells Pandas to find the file, open it, and load all the data into a special structure. What is this special structure called df? In Pandas, the main object we work with is called a data frame. You can think of a data frame as a smart table, much like a sheet in Excel but with superpowers. It has rows and columns, just like a regular table. Each column has a name, which we call a header, like name, subject, or marks. The first function we can use is head. As the name suggests, it shows you the head or the top part of your data. By default, df.head will show you the first 5 rows of your data frame. This is extremely useful to quickly check if your data has loaded correctly. You can see the column names and the first few entries. If you want to see more or fewer rows, you can pass a number inside the parentheses. Just like head shows you the beginning of the data, tail shows you the end. If you use the command def.tail, it will display the last 5 rows of your data frame. Sometimes, errors or strange values can appear at the end of a file. The df.info function provides essential information about your data frame. It tells you the number of rows and columns, the name of each column, the number of non-empty values in each column, and the type of data in each column, like numbers, text, or dates. The df.describe function gives you a statistical summary of the numerical columns. It will show you the count, mean or average, standard deviation, minimum value, maximum value, and other important numbers for columns like marks. It's a powerful way to understand the distribution of your numerical data at a glance. After getting a first look at our data, we often need to focus on specific parts of it. We might not be interested in all the columns, or we might want to look at only certain rows that meet specific conditions. This process of picking the data you need is called selecting and filtering. Imagine you have a large library of books. Selecting a column is like deciding to only look at the book titles. Filtering rows is like deciding to only look at books written by a certain author. First, let's talk about selecting columns. A data frame is made up of columns, and each column is called a series in Pandas. If we want to look at just one column, say the subject column from our student marks data, we can do it very easily, df subject. This will show us all the values from the subject column. If we want to select multiple columns, for example, name and marks, we can pass a list of column names, df, name, marks. Notice the double square brackets. Now let's move on to filtering rows. This is where the real power of data analysis begins. We can ask specific questions to our data. For example, what if we want to see only the records where the subject is maths? df subject == maths. This expression checks each row and returns true if the subject is maths and false otherwise. To get the actual rows, we place this condition inside the square brackets of our data frame, like this, df subject == maths. This command will return a new data frame containing only the rows for the maths subject. We can also create more complex conditions. What if we want to find students who scored more than 90 marks in any subject, df marks 90? We can also combine multiple conditions using and for and vertical bar for or. For example, to find all the records for the science subject where the marks are greater than 85, we would write df subject == science and df marks 85. To answer such questions, we need to group our data. This is where the GroupBy function in Pandas comes in. It's one of the most powerful features. It lets us split our data into groups based on criteria. Tell Pandas to group by the subject column. Command df.groupby subject. That creates a GroupBy object. It splits data into groups for maths, science, English, and so on. Now tell it what to do with these groups. Calculate the average of the marks column for each group. Select marks, specify mean, average. Command df.groupby subject. Marks, mean. Run it. Pandas does the work. Maths, average calculated. Science, average calculated. English, average calculated. Result, neat table with subject and average mark. GroupBy works with other calculations too. Highest mark per subject, use max. Command df.groupby subject. Marks, max. Total students per subject, use count. Command df.groupby subject. Name, count, multiple aggregations, use agg. Command df.groupby subject. Marks, ag, mean, min, max. In the real world, data is often not in a single file or table. It's usually spread across multiple tables. Let's imagine we have two data frames. The merge function will match roll_no across tables and combine the rows. pd.merge students_df marks_df on =, roll_no. The first two arguments are the data frames to join. The on=, roll_no. Argument tells Pandas which column to use as the key. A pivot table reorganizes your data to highlight relationships. df.pivottable, index and name, columns and subject, values and marks. The index and name part tells Pandas to use the unique values from the name column as the rows of our new table. Pivot tables reshape and summarize data. They let you quickly switch views and reveal insights hidden in the original format. We have covered a lot of ground today. Let's take a moment to quickly recap the amazing things we have learned that Pandas can do. We started our journey by understanding that Pandas is a powerful Python library for data manipulation, a data scientist's best friend. It helps us make sense of large amounts of data in a simple and efficient way. We saw that the core of Pandas is the data frame, which is like a super smart table where our data lives. Our first practical step was loading data. We learned the pd.read_csv command, which is our gateway to bringing data from external files into our program. Once the data was loaded into a data frame called df, we learned how to get acquainted with it. We used df.head to see the top rows, df.tail to see the bottom rows, df.info to get a technical summary, df.describe to get a statistical overview. Then we dived into the core of data manipulation. We learned how to select one or more columns using square brackets like df column name. More importantly, we learned how to filter rows based on conditions. For example, df marks 80 gives us all the high-scoring students. We then explored the powerful GroupBy function. With a command like df subject, marks and mean, we could easily calculate summary statistics for different groups in our data, revealing important patterns. Finally, we looked at more advanced techniques for handling real-world data scenarios. We learned how to use pd.merge to combine two different tables based on a common column, which is essential when data is spread across multiple sources. We also discovered the pivot_table function, which allows us to reshape our data and create summary tables similar to those in Excel. All these steps, from loading to pivoting, form a complete toolkit for data analysis. So, we have seen how Pandas can help us load, inspect, clean, analyze data in just a few simple steps. It's kind of like having a superpower that allows you to talk to data and ask it questions. Whether you want to know the top-selling products for a company, the change in weather patterns in your city, the academic performance of students, Pandas provides the tools to find the answers. It makes data analysis accessible to everyone, not just expert programmers. The real beauty of Pandas lies in its simplicity and its power. The commands are intuitive and easy to read, almost like plain English. This makes it a perfect tool for beginners.